Yeah, good afternoon, sir. Myself, Shishidhar Reddy, and my registration number is 19BC1646. So, this is my digital assignment 3. So, my topic is the Algam crypto system. Normally, I'm going to discuss about the public here. The overview of the topic is I'm going to discuss about the public key cryptography and Algamal crypto system and importance of its correct implementation and summary. Then afterwards, the public key cryptography, it was introduced in the year of 1976 by the DeFi and Hellman. The features of this public key cryptography is sender verification and private key remains at owner. Here, the public key is a distributor freely and no secret channel necessary for transferring the message from one to one and no pre-shared keys. Yeah. It's a prominent, it's mainly used in RSA, Elgamal, and it's now let me explain the public key cryptographic procedure by using a scenario. Let us consider it's like an example. Okay, here now Alice wants to send an encrypted message to Bob. So here we will discuss now how public key is helpful for sending the encrypted message to Bob. So, firstly, Bob needs to compute a pair of keys, which is a public and a private key. Now, Bob publishes it's a public key to the sender's thing, to Alice. So now Alice encrypts the message using its Bob's public key. Now Alice sends after encrypting the message, the Alice sends a message to the Bob. Bob encrypts the message, decrypts the message using its private key. If the message decrypts successfully, then it's the correct message. Otherwise, it's the wrong message. In this, nobody interception, nobody cannot intercept the message can read. See, there's a schematic diagram of the um, procedure what we have discussed just now. Here, uh, simply allies encrypts a message using public key. I mean, first Bob shares the public key to the allies, then allies encrypts are using a public key, and it sends ally sends an encrypted message to the Bob, and Bob decrypts or encrypts using his own private key, so he can see the message. No one can interfere in this process. The algorithm. For this algorithm, mainly need two public parameters like a p. Simply is a public key. Is a p is a prime number, g is a generator, and uh, features of public key cryptography. It's able to set up a secure channels between two parties. It will be as discussed before. It's based on a discrete logarithm problem, I mean algorithm. Uh, Elgamal um, is also depends on the discrete logarithm algorithm for the encrypting and decrypting. The problems what we have faced, I mean, what I've read once researching about this Elgamal crypto system is uh, in a public cryptography is vulnerable to middleman attack, vulnerable to chosen plain text attack like a signed keys, not useful for one-way communication. Now, now we'll get to the Elgamal crypto system. It was mainly presented in the year of 1984 by Tat Elgamal. Its main key aspects of this topic is as I told, it's based on a discrete logarithm problem and randomized encryption. Application. Anyway, it's useful for establishing a secure channel for key sharing. It's useful for encrypting messages. The mainly normally in an Elgamal crypto system, it's an asymmetric key encryption algorithm. based on a Diffie-Hellman key exchange. The system, I mean, the Elgamal crypto system provides an additional security based on additional layer of security by asymmetrically encrypting keys previously for message encryption. Totally consists of three components like a key generation, encrypting the algorithm, and decrypting algorithm. Now now we'll discuss about the key generation thing. Here, let's consider participant A generates a public and private key pair. Then we need to have generate the large prime number P and generate a G of the multiplicative group GP, PF of the integers modulo P. And we have to select an integer where it lies between 1 to P minus 2 and compute G power A mod P. As A's public key is P, G power A, and A's private key is A. I'll clearly explain this part while using an example later. Now we're going to take the encryption procedure. Now participant B, like participant B means here Bob, encrypts a message M to A. A obtains B means alias, okay. Obtains A's public key, PAG power A, represents this message as integers M in the range of 0 to P minus 1. Here M is a message. We have to select a random integer between K 1 to P minus 2. K lies in the range of 1 to P minus 2. And we have to compute gamma equals to G power K as we discussed here, like 1 second. Yeah. This in G power K mod P and gamma equals M into G power A power K. We'll get the ciphertext. We have to send the ciphertext to A. Now we'll discuss about the decryption procedure. Here participant A receives the like here Bob receives the encrypted message from allies using now Bob using his own private key A to compute alpha or P minus 1 A mod P. Recover M by computing the alpha minus A into gamma mod P. After computing, we'll receive the message decrypting. After doing this all procedure by decrypting, we'll receive the message what was sent by the allies to the Bob in a secret way by not losing any message or not interfering anyone in between. So yeah, let us I'll explain with an example here. Alice chooses public key 1767, which the prime is P equals 17, G equals 6, and private key equals to 5, A equals to 5. And private key part G power A, you can calculate the G power A mod P equals G power 5 is 17. So here Bob encrypts his message M equals to 13. Your message we're going to encrypt. First, we're going to encrypt the message M equals to 13. It chooses a random value K equals to 10. It calculates alpha equals to 4, K, P equals to 4, 10, mod 17 equals to 15. 15. Here it encrypts gamma. So delta equals to M G power K mod P 9. Bob sends alpha delta equals to 15 and gamma equals to 9 to allies. Now using the decryption algorithm, we're going to do so. His public key is P G power A. So now we have the decryption factor here. We have gamma power minus A into delta mod P equals to 15 minus 5 mod 17 equals to 9. Decryption gamma into 9 into mod P equals 99 mod 17 equals to 13. So alias here we can see here alias has now decrypted the message and received the 13. This successfully decrypted means no one has interfered while transferring the encrypted message from alias to Bob. So here decryption is successful. So Elgamal crypto system summary. Use of a random factor K for encryption, variant of DH shared security G power AK. Duplicates message length depends on interactability, DL and DH. It's important. Now we'll discuss about the importance of CANT implementation. Now I'm gonna explain you regarding one example. What I've done with I've taken a some example values from the net, and I've done this problem. See that the main the main part. I mean, as I discussed, Elgamal crypto system consists of mainly three parts: key generator algorithm, key generator, and encryption algorithm and decryption algorithm. And firstly, let me explain with an example. Here, I took a now here, let me explain you the Elgamal crypto system using an example. Uh, by using an example, it will be clearly and understood. I mean, we can understand it clearly, easy way, easy matter. So normally, Elgamal crypto system, it's an asymmetric crypto system. Asymmetric crypto system. It's an asymmetric crypto system, key encryption algorithm. It's based on a Diffie-Hellman key exchange thing, and the system provides an additional layer of security by asymmetrically encrypting keys and previously for message encryption. So it mainly consists of three parts here. We've seen that key generation and the key encryption algorithm and decryption algorithm. So mainly for for first thing in the Elgamal crypto system, we need to um, generate the private and public keys for the sender. So here a public key, let us take the public key as PGY and private key as capital X. And when Alice wants to send message to Bob, so I've taken a scenario here. I want Alice wants to send message to Bob, but no one should see the message and no one should interfere in the message. So by using the Elgamal crypto system, firstly, I've generated the keys. Here simply I've taken example questions and solved using the procedure using Elgamal crypto system method algorithms and logo. Firstly, you have to generate the keys. I've taken example from the internet where G equals to 3, P equals to 101, K equals to 6, here a message equals to 5, and X equals to 2. So normally Y will be given in the question itself, but if not also no issues, we have that equation for that thing to find the value of Y. So the equation is Y equals to G power X mod P. So by using this equation, we can we're gonna find the value of Y. I mean public key of one of the public key. So here Y equals to G power X mod P, where G equals to 3, X equals to 2, mod P equals to 101, 9 lies and before the 101, so Y equals to 9. Then the second part. Now the second part, will go to the second part. It only consists of three parts: key generation, encryption, and decryption. So first part is completed. Now we'll go to the second part, encryption thing. Here we need to, for the encryption, we need to find the two values. While encrypting, we'll get the two values where C1 equals to ciphertext, where CRC. So to calculate the R, we have the right equation where where R equals to G power K mod P, where G, we know that G equals to 3 and K is given, K is taken as 6. It's a random value you can take, and K is taken as 6 and mod 1 P equals to 101. So 3 power 6 equals to 729 mod 101. So 729 or 11 1017 is 707, 729 and 707 equals to 22. R equals to 22. We got the R value as 22. And now we have to calculate the C value. We know that rightly equation C equals to M into Y power K mod P, where M equals to 5, which is a message string, and Y equals to 9 is given, and K value is 6, and mod P equals to 101. Well, 5 into, we get the 946 value as 531441 mod 101. After calculating this thing value, you get the C value is 97. So now here the ciphertext RC1, it's a ciphertext RC 22 common length. So we got the value of ciphertext. Now here the Alice sends the ciphertext to the Bob for decryption, to help in the decryption thing, for decrypting his message. So now here the Bob want to decrypt his message. So for decryption thing, we have the equation here, or all in the algorithm, the procedure is D equals for decryption thing C of R or P minus 1 minus X mod P mod P. So where we found out the C value is 97 in the previous encryption step, and the R value is 22. So after getting 92 into 22 or 98 mod 101, it's not easy to calculate the 22 or 98. So we're going to calculate these things. So 97/2, 22 per 7 into mod 101 whole power 14. We're going to simplify these things. Lastly, we'll get 92, 97 into 67 square into 58 into mod 101. So after solving this part, we'll get the values 5. I've solved using a calculator. I got the value of 5. Here's the value of is the 5 is equals to the message part. Message is equals to 5. So here the decryption using successfully done using the Elgamal crypto system. So when we receive the message successfully, it means we have it's a successful state. No one has interfered in the between while sending, encrypting, or decrypting the thing. No one has interfered the thing. No one has used his own private key to decrypt the thing. So thank you, sir. This is my DA-3. Again, my topic is Elgamal crypto system and myself, Shashidhar Reddy, 19 BCE 1646.